8.2 is on the converse of the Pythagorean theorem. So this section, we are going to be classifying a triangle when given three side lengths using the converse of Pythagorean theorem. The converse of Pythagorean theorem tells us that if c squared equals a squared plus b squared, then triangle ABC is a right triangle. So for example 1, we are going to determine if the following are right triangles. Remember, c squared is always going to be the largest value. So in this case, c is going to be 3 square roots of 13. We are going to plug it into the formula to see if this is going to be a right triangle. When you type 3 square roots of 13 squared into your calculator, you need to make sure you have these parentheses and that the squared is outside of the parentheses. If you don't, your calculator is going to follow PEMDAS and it might give you the wrong answer. So for this one, we are going to end up with 117 as our answer on the left side. And then when we type in 6 squared plus 9 squared, and check that one, we will also get 117. So this one is a right triangle. Just get a little bit smaller. There we go. Now you can go ahead and try example B on your own, and then if you press play, you can check your answer. So for this one, when you set it up, you could have had 29 squared equals 24 squared plus 16 squared. And again, I'm just going to go to my calculator, type this all in, 841, and then we have 24 squared plus 16 squared, which equals 832. Now these are close to each other, but they're not equal to each other. So this one would not be a right triangle. Not a right triangle. And that would be our answer. So that's how we can tell whether or not it's right or not. This table on this is going to be important. You are going to want to have this memorized for quizzes and tests. So in the following table, we are going to be using triangle ABC, and we're going to be determining the type of triangle based on its angles. So we already know if we have a squared plus b squared equals c squared, that we have a right triangle. That one we've already gone over. Now, what happens if c squared is less than a squared plus b squared? In that case, we're going to have an acute triangle. So they kind of go together. So less than, acute, smaller, those words kind of relate to each other. So it's easy to remember. If c squared is smaller, it's going to be acute. And then if c squared is greater than a squared plus b squared, that's when we get our obtuse triangle. So obtuse is when our triangle has the c squared being the largest value. And that's what we're going to use to classify the triangles. So the first thing we're going to have to do is determine whether or not the three sides formed are a triangle. So example 2 says, can segments with lengths 2.8 feet, 3.2 feet, and 4.2 feet form a triangle? So to determine if three sides can form a triangle, we have to show that the sum of the two smaller sides is greater than the third side. So in this case, we're going to take 2.8 plus 3.2 and see if that's greater than 4.2. And when we add those together, we're going to get 6 is greater than 4.2, which is true because it does form a triangle. Now we can classify the triangle as acute, right, or obtuse using the Pythagorean theorem. When we write this out, always start with c squared. If you start with c squared, then you won't be confused, and hopefully that'll prevent you from mixing up your answers between acute and obtuse. So plugging this in, we're going to end up with 4.2 squared box. And the reason we put the box is because we don't know what goes in there yet. So that's why we put the box. And then we'll have 2.8 squared plus 3.2 squared on the right side. And 4.2 squared is 17.64. And then if we take 2.8 squared plus 3.2 squared, we're going to get 18.08. Once you have the number values on each side, what you are looking for is which one is bigger, and that is going to be the 18.08. So if we put that into our box, we know that a squared plus b squared is bigger than c squared. So because c squared is smaller, this is going to end up being an acute triangle because c squared is smaller. So if you want to try the last example on your own, trying to identify what type of triangle it is, pause the video and then press play once you have your answer. So for this one, we're following the same steps as our last example. We're first going to determine whether or not this can form a right triangle. A triangle, not a right triangle. And if we were to add these two smaller sides together, we would get 15.5 is greater than 11.3, which is true, so we know this forms a triangle. Now we need to figure out what type of triangle, so we're going to plug it into our converse of Pythagorean theorem to see if it's equal to, greater than, or less than c squared. And in this case, c is 11.3, a is 6.1, and b is 9.4. Now we can plug this all into our calculator to see what they equal. 11.3 squared is 127.69, and then we just need to type the 6.1 squared plus 9.4 squared, and that gives us 125.57. So again, these numbers are pretty close to each other, but they are not the same, so we cannot say it's a right triangle. They have to be exactly the same. So in this example, c squared ends up being the bigger value. So because c squared is bigger, that tells us we have an obtuse triangle. And if they were equal to each other, then we could say that it is a right triangle. So those are all the notes for this section. If you have any questions on them, please let me know and I will get back to you as soon as possible.